Basic data analysis of Y. This slide explains how we use Minitab run charts to assess the stability of a process. Stability means that the data behaves randomly with no visible patterns over time. If a process is unstable, it may indicate underlying issues or changes affecting performance. A run chart is a simple but powerful tool that helps us identify these patterns. There are four main types of patterns to watch for. Trend. Data moves steadily upward or downward over time. Mixture. Data avoids the centerline or median. Oscillation. Data fluctuates rapidly above and below the median. Cluster. Data points are bunched together, indicating potential grouping. Minitab automatically checks for these patterns and provides p-values for each. Here's how to interpret them. If any p-value is less than 0.05, that pattern is likely present, and the data is considered not stable. If all p-values are 0.05 or higher, the data is considered random and stable. The chart on the right demonstrates how different types of instability can appear. A trend is seen in the rising sales data. A mixture is identified in temperature readings that avoid the center line. Oscillation is observed in machine outputs that frequently swing above and below the median. Recognizing these patterns helps us understand whether a process is behaving consistently or if there are issues we need to investigate. This slide shows how to generate and interpret a run chart in Minitab to assess the stability of a process. We break it down into 3 steps. Step 1. This is how we initiate the run chart generation process. Step 2. In the dialog box, select the appropriate column of data. In this case, it's total breakage. Set the subgroup size to 1 and make sure the data is correctly arranged for individual observations. Step 3. Once the chart is generated, Minitab provides p-values for 4 patterns: cluster, mixture, trend, oscillation. Now for interpretation. If all 4 p-values than 0.05, we accept the null hypothesis, H0. This means the data is random and stable. There's no significant pattern. However, if one or more p-values are less than 0.05, we accept the alternate hypothesis, HA. This indicates that a pattern is present and the data is non-random and not stable. Looking at the example, clustering has a p-value of 0.013. Trend is 0.021. Mixture is 0.887. Oscillation is 0.970. Since 2 of these p-values are less than 0.05, we conclude that the process is non-random and unstable. Understanding and interpreting these results is crucial in identifying underlying process issues that might need corrective action. Normality test. This slide provides a basic understanding of a normality test, which is used to determine whether our dataset follows a normal distribution. This is important because many statistical analyses, like t-tests, regression, and ANOVA, assume that the data is normally distributed. We commonly use tests such as Shapiro-Wilk, which is suitable for smaller datasets, Kolmogorov-Smirnov, which compares our sample to a standard normal distribution, and Anderson-Darling, which pays more attention to the tails of the distribution. In addition to these tests, visual tools like histograms, QQ plots, and box plots can help us assess normality intuitively. When interpreting results, if the p-value is greater than or equal to 0.05, we conclude the data is likely normal. If the p-value is less than 0.05, the data is not normally distributed. Understanding whether data is normal helps us choose the right statistical tools for analysis. This slide explains how to perform and interpret a normality test in Minitab using the p-value. Step 1. Running the test. Navigate to Stat, Basic Statistics greater than Normality Test. This opens the dialog box where we choose the variable we want to test. In this example, we're testing the normality of total breakage. Step 2. Selecting the method. You can choose from multiple normality test methods such as Anderson-Darling, Ryan-Joyner, or Kolmogorov-Smirnov. These methods analyze whether your data follows a normal distribution. Step 3. Interpreting the probability plot. After running the test, you get a probability plot like the one shown here. On this chart, we see red dots representing our data plotted against a straight diagonal line, which represents a perfect normal distribution. The key element to focus on is the p-value. If p-value less than 0.05, we reject the null hypothesis, H0. This means the data does not follow a normal distribution. If p-value to 0.05, we fail to reject the null hypothesis. So, we conclude that the data is normally distributed. In the example, the p-value is less than 0.05, so we conclude that total breakage is not normally distributed. In summary, a low p-value suggests a significant deviation from normality, while a high p-value suggests the data fits a normal distribution well. This is crucial when choosing appropriate statistical tools, especially those that assume normality. Graphical summary. This slide explains how to generate and interpret a graphical summary in Minitab. Step 1. Accessing the tool. Go to Stat, Statistics, Graphical Summary. This opens a dialog box where you can select the variable of interest. In our case, we're analyzing total breakage. Step 2. What you get. The graphical summary provides a histogram with a normal curve overlay, a box plot for detecting outliers, confidence intervals for the mean, median, and standard deviation, and importantly, results from the Anderson-Darling normality test. Step 3. Interpreting the results. Focus on the p-value in the Anderson-Darling test. If p-value less than 0.05, we conclude the data is not normally distributed. If p-value equal to 0.05, the data is considered normal. In this example, the p-value is less than 0.05, indicating that total breakage is not normally distributed. Why use graphical summary? It's very powerful because it gives you both numerical outputs and visual tools in one view. This helps in identifying spread, central tendency, skewness, and potential outliers effectively. Conclusion. Don't rely on the p-value alone. Use the histogram and box plot together with the p-value to make a complete judgment about the data's normality.